Welcome to this video about ions to help you out. So here's the PowerPoint. Let's start. So an ion is a charged atom. So basically up to this point we've talked about something that had the same number of protons and electrons, an atom that's balanced, that's neutral. What we're going to learn is that the number of electrons can change. And when the number of electrons changes, the charge obviously is going to change. So you have to remember a couple of things. The charge of a proton is positive. The charge of an electron is negative. So with that in mind, if I change the number of electrons, I'm going to basically change the charge of the atom. So meaning if I add electrons, it's going to become overly negative because I've added something that's negative. If I take electrons away, well then it's going to become less negative, more positive because I took the electrons away. So keeping in mind the balance between protons and electrons as we go through this, okay? So the charge is usually the difference between the protons and the electrons. Okay, if there's more protons than electrons, it's going to be positive. If there's more electrons than protons, it'll be negative. Okay, so these are words that you need to know. So we have an anion, more electrons than protons. This is going to be negative. It's going to be formed when you gain electrons. You're adding that negative charge. You're adding all those negatives. It's going to become overall negative. I had a student once tell me a way to remember this is to think of anion like an onion, because it kind of looks like the word onion. Onions make you cry, kind of a negative thing, right? So it helps that student remember that anion, onion, negative, negative charge, okay? If that works for you, use it. If not, don't use it. On the other hand, we have cations. Cations are positive. They are positive. There's more protons than electrons. This happens when we lose electrons. We're losing the negative charge, thereby getting more positive. Okay, cat is in the name cation. It's a clever way to remember this. If you figure cats have paws, cations are positive. Get it? Get what we did there? Yeah. Also, there's a T in the word cation. Might also help you that these ions are positive because the T kind of looks like a positive sign. So please use whatever method you want. You are responsible for knowing these names. We're going to use the names often, and it's very easy to get confused. So just try to take the time to commit that to memory. Okay. Oxidation. When an atom loses electrons, very simple. Ions are going to be smaller than the original atom, so they've lost an electron. They're going to be smaller. Makes sense. If you lose a lot of weight, you're going to be smaller. So losing electrons, you're going to get smaller. Okay, who tends to do this? Metals. Metals are big fat losers. So all the metals that you know and love, silver, iron, etc. These guys are big fat losers. They lose electrons, and that's okay. This is what happens when iron rusts, which is really interesting to think about. Okay, so what's happening is the iron is losing its electrons to oxygen, the oxygen in our normal atmospheric air, 21% oxygen. The oxygen wants to gain electrons really badly, wants to gain 2 more specifically, and iron is so happy to oblige and give him those 2 electrons. So iron is the loser here, losing the electrons, actually kind of making him a winner if you think about it. He combines with oxygen, who desperately wants to take those electrons, and they make this wonderful compound called iron oxide that is rust. Rust, that red stuff that you see that builds up on steel, on iron, that is what we call rust. Okay, so it's an actual new compound. And this whole process of losing electrons, though, is called oxidation, The opposite of this, ding, 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 is reduction. But here, let's look at the formation of a cation. We have a sodium. Sodium, again, pretty nasty stuff by itself. Remember, when you put it together with chlorine, you end up with something very friendly. But here's our normal sodium, just elemental sodium. What's going to happen is, boom, it's going to lose an electron. And by doing so, Ding, ding, ding. We have the sodium ion. Whoopsie. Which is where did it go? Hold on. We did oxidation already. Technical difficulties. Okay, we did that. We did oxidation already. Okay. Now, we have our cation. We're going to lose our electrons. So here's back to sodium again. Boom. And then we have sodium ion. Ding, ding, ding. Okay. Reduction. I don't know why this keeps happening now. Boop, boop, boop. Okay, reduction. When an atom gains an electron. So if it didn't lose, it gained. So reduction is a little different than what the sound, not the sound, but what the word means in our normal daily life. Reduction usually means you're getting smaller, but in this case, reduction is you're gaining an electron and they're actually larger. So it's a little bit of the opposite. And the reason why it's opposite, if you think about it, is you're gaining something that is negative. So you're gaining an electron. Electrons are negative. So technically you're gaining a negative number, a negative value, which is kind of where the reduction name comes into play. So you're literally you're gaining electron, but you're gaining a negative number, which in turn changes the the sign. So you end up being a negative ion, which is what we call an anion. So we are becoming more negative. Nonmetals tend to gain, so our metals were big fat losers. Your nonmetals are big fat winners, basically. They want to gain electrons. So in the case of rust, what we talked about before, oxygen was the nonmetal, and oxygen wanted to gain the electrons that iron so desperately wanted to lose. Okay, so one loses, one gains. In our case, metals are losing, and the nonmetals are going to gain. So here's our chlorine. He's a nonmetal. And what we're going to see from him, and really, if you didn't know that, you could just kind of take a look at the outside valence shell here, and you could see 1, 2, 3, 4, 5, 6, 7. I have 7. And what's the magic number in chemistry? 8. So we're really missing one electron here. And wouldn't it be swell if chlorine could just gain one more electron? And sure enough, that might be what he does. Look at that. Gain of one valence electron. Boom. And we now have a lovely chloride ion that has a -1 charge. Now look at this. It gains an electron. It gains an electron. But it's still, or it's not still, but it turned negative because of that negative electron. And this process is called reduction because you're increasing that negative charge. All right, lithium ion, for example, 3 protons, 3 electrons. How do we get it to be like a noble gas? It wants to lose an electron so that it can get its magic 8 because it wants 8 in that last shell. So it loses that electron and it becomes a lithium ion because it has the electron configuration of a noble gas. And that's what they all achieve to be. Sodium atom is in the same book as lithium. It so desperately wants to lose an electron. It wants to be like a noble gas. It wants to gain that new nobility. And so it does that. It loses its electron and it turns into sodium ion with a 1 positive charge because it lost that electron. There's more protons than electrons in this case because it lost the 1. So you can see the unbalancedness here. 11 protons versus 10 electrons. Positive 1 charge. Boom, boom, boom. Sodium would rather be a sodium 1 plus ion. It just makes more sense. He's just happier that way because then he has 8 valence electrons, and that's what we want. All right, so when you're naming ions, you're going to use the elemental name and then say the word ion. So for example, you have calcium ion, cesium ion, aluminum ion, okay? Calcium, cesium, aluminum. Anion, so those are your cations, they are positive. Anions, you're going to change the ending of the element's name to ide, I-D-E, and then you're going to say ion. So here's some examples, and this is just you're learning a new language, you need to know how to speak it properly. So it's really important that we learn the rules of our language so that we sound like professional chemists that we are. So here's our first example. We have an S. And again, if you don't know the names of these guys, you can look on your table S in your reference table to find the names for the symbols. So you don't need to memorize, you just need to look it up, folks. All right, so sulfide. So instead of it being sulfur, it turned into sulfide, and then we just say the word ion. So this is a sulfide ion. The next one is going to turn into phosphide ion. Nitride for nitrogen ion. Oxygen turns into oxide ion, and then chlorine goes into chloride ion. And the other one that you guys have probably commonly have heard about is fluorine. When that turns into an ion, like the stuff in your toothpaste, basically, you have, instead of it fluorine, it turns into fluoride. And that's when people talk about the fluoride in your water, the fluoride in your toothpaste, etc. They're referring to fluorine in an ion form. So what happens is it gained an electron, probably in a compound with something, and now it is fluoride instead of pronounced fluorine. So here's some various ions here. You could see the stuff on the, what is this? This would be considered your left, my left too. So the stuff here on the left is going to be positives. These are your cations, these are your metals, they want to lose. Your transitional metals here on your periodic table, these guys want to lose too. Okay, this again, this is just an outline of your periodic table. Over here, we still have some losers here. Note their positive charges. They're cations, they lost electrons. But over here, we have some negative folks. And these guys want to gain the electrons and become negative ions here. So these are your nonmetals. All over here are your metals. Clearly, the metals are the winners.